Hello Blender community. For this tutorial we're going to look at how to do strings, wires, ropes, extension cords, etc. And we're going to be using the character physics plugin. So for information on that, look at the video description. Alright, getting to the tutorial. Alright, let's start with the basics. So once you have the character physics add-on installed, over here in the 3D view, in this panel that pops up when you hit the N key, you should get a new tab that says Character Physics. So you're going to want to click on that Character Physics tab. There's nothing much in here at the moment because we don't have any objects in the scene. So let's add an armature. And now that we have our armature, we have all of these lovely options that pop up. And we're going to simulate a wire. So let's make this into something that approximates a wire or something you might use to animate a wire. So we're going to extrude it on the z-axis, value of 1, and then just going to repeat that action until we have something like a long piece of wire. One more. Now, for this to work, the character physics thing is designed to work with a pose target. It's mostly for characters, so like you would have your pose target, which would be where you would set poses, and then the physics target is going to try to match those poses in a physics environment so that you can have characters like walking around on terrain and stuff. But we also need to use it for our cable system, because it's mostly designed for characters. It just happens to work really well for ropes and cables and stuff like that also. So to do that, we need it to match the number of bones and the configuration of bones, so I just duplicated it. And now this is going to be our physics guy, and this is going to be our pose target rig. And maybe we'll just name this like phys rig. Now, over here in our options, this is the pose target right here. So I'm going to eyedropper this guy, my pose target. And when I do that, it creates a physics visualization mesh, which is literally just a regular old Blender mesh with shape keys and stuff. And I'll talk more about this in a minute. Alright, now that we have our physics visualization mesh and our pose target, it should just, once the timeline starts moving, every time the frame changes, the physics runs one physics step. And it doesn't run back and forth like a typical animation, it just updates anytime this moves anywhere. And if you want to get it back to its starting state, which it's currently falling because gravity by default is set to 1, you can just, while you have either one of these guys selected, either your pose target or your physics target, you hit reset and it will set it back to its starting state. For simplicity and also as a useful feature, you can set the frame reset right here to whatever frame you want, and it will automatically reset whenever you hit that frame. So see how it's just running physics forward in time, keeps falling no matter what frame I scroll to. If I go to frame 0, it's going to reset it. So there we go, we reset. Now, obviously we don't want it to just fall, we want to be able to control it. So to control it, we're going to go into pose mode. So with your armature object selected, control tab to go into pose mode, and we want to put a control target on it. So in this case, I'm going to add a tail target, which is basically the simplest thing, and it adds it at the tail of the bone. This would be the head of this bone and the tail of this bone. So tail target makes this empty, and it currently doesn't do anything because there are no forces set to any value above 0. So to make it do something, with our bone that has the target selected, we set the spring value to 1, and what that means is that the bone will move towards this target with a force of 1, which means it'll be exactly where this is at all times. So now with it running, I can move it around, and the physics mesh is moving wherever I put this. The armature is out of sync with it, and that is because the armature automatically has these parents, and it doesn't allow any kind of stretch. So there's a couple of things you can do. The first is you can just change the number of linear iters to stiffen it, and that will make it a little more accurate, but it's not exactly perfect. So to allow the armature to stretch, you're going to go over here and clear parents. When you do that, now your armature will move where the physics visualization mesh says it should move, which means that it will animate your objects correctly once you start using this armature to animate something. So we hit clear parents to do that. And if you want to start over again, you'll need to connect the parents back. And to connect the parents back, so if you want to change the number of bones or something like that, but you still want to use this rig, and you don't want to create a whole new rig from scratch, you can hit connect bones and it will reset those parenting relationships based somewhat on a guess as to what your parent relationships probably were when you started. So use that with caution and verify that it's working the way you expect. Alright, now that we've seen the basics of how to use this, we don't need this nonsense anymore, so we're going to try to animate something interesting. So I modeled this lovely lamp a few minutes ago for this tutorial, and this extension cord. It's not really a modeling tutorial, so I'm not showing that part, but it's pretty easy to find tutorials for doing that kind of stuff. What we're going to do is animate this cord being sort of wound up and being plugged in. So we need to create an armature for our extension cord. And I kind of want it to be the size of the whole cord, just for making it easier to understand what's going on. So just going to do like this, and I kind of want this first segment to not really deform, so it's kind of like it's stiff here. So for that reason, I'm going to move that bone up to this first section right there. And I have my snap turned on, so I'm just going to do that and snap it to that spot. So this bone is going to control the plugin, and then I conveniently used an array modifier to space segments every one blender unit here for convenience, and I'm going to put armature bones like every segment. So for that, I'm going to extrude it X and maybe snap to that segment, and then I can repeat it until I get all the way to the end of my extension cord. Ta-da! Alright, now I want this cord to be deformed by this guy, so I'm going to select my cord, and I'm going to select the armature, and I'm going to do Control P, and we're going to let it do automatic weights. And in theory, if that worked correctly, I have this set to rotate individual origins, and I have them all selected. So indeed it does warp my cord. It does not move the head yet because I haven't done anything with that, so we're going to select the head and the armature again, go into pose mode and select that bone and Control P, and we're just going to parent that to the bone. So now my whole thing moves the way that I want it to. Okay, now I'm going to start throwing some physics into this equation. Well, with our physics rig selected, this is going to be our physics rig. So maybe I'll just call it that, just because. Phys rig. Now there's a dead one somewhere hidden, so it automatically renamed it. I'm going to now duplicate this so I get a pose target. And I'm going to set my pose target for my physics rig to be that one I just duplicated. And now when I start animating, it starts to fall because gravity. And I'm going to set it to reset at frame 0. So 0. And now when I go back to frame 0, it's going to reset. And I'm going to start by putting in a target. So in this case, we'll do a head target, and that's going to place this target at the base of the bone, or at the head of the bone. And I'm going to set the spring force to 1. And now when this thing runs, it's going to move with that head target. We also want to be able to control the rotation because we're going to try to plug it into a socket a little bit later here. So to control the rotation, we want to add, we're back in pose mode, we select that bone and we add a rotation target. So head, tail, rotation. And the rotation target settings appear down here. And you know, the empty that it's using is listed right here. So we're going to set the rotation also to 1. And incidentally, if you set this to some value other than 1, so like we set the spring value to a smaller value, then it will have some effect, which in this case it's having a conflict because of the rotation and the tail target. So actually let's just kill the rotation target for a minute so you can see. So it's not following it exactly. That's so you can add like multiple influence targets and do other things with it. And once you set that back up to 1, then it sucks up tight to it. Alright, back to frame 0, reset. So let's try just creating that again. Rotation target, set this to 1, and now it behaves the way that I want it to. So with my rotation target, wherever I rotate this, it will match. Now it doesn't care about the location, it's just copying its rotation, kind of like a rotation constraint would. To make this easier to control, we're going to make this guy the child of this guy. And now I can just select this and I can control the location and the rotation, which will allow me to go and plug this thing in when I go to, you know, plug it in. And you'll notice it's pretty floppy. To make it less floppy, you can turn up the angular itters and it will make the cord stiffer. Now, the more angular itters you run, the more it sort of has to process, so it's going to get a little laggy. But don't worry too much about the lag because you can set things up the way you want it and then just let it run and record everything. It'd be kind of like baking a cloth simulation or a physics simulation or doing a render or something. You get everything the way you want it and then you run it at full resolution. So you can set it to lower resolution while you're experimenting with it, just so that it's a little bit easier to work with. And of course, you know, you're probably going to want to turn up the linear itters to make it a little bit stiffer. Linear itters don't take as much to compute, so you can play with those with a little bit more freedom. Alright, now we've got one end correctly controlled, but the other end is still just sort of flopping all around. So we're going to fix the other end. I'm going to go over here to our other end like this, and we're going to add same thing, the head target, and set it to 1. And a rotation target and set it to 1. Alright, and now that we've got this, theoretically when we run this, yep, this side is also fixed. So notice our physics mesh is where it should be. The armature is not doing what we would want it to do because it can't stretch again, so we're going to fix that. We're going to just clear parents. If you disconnect bones, it keeps the parent relationships, but gets rid of the connected state so that there can be an offset. I found that if you record while you do that, you still have the parented bones with offset, then the movement of the head bone, or the base bone with all of its children, it's going to look kind of glitchy, so just go ahead and disconnect the parents, or so click on clear parents. And that will allow the armature to deform exactly with the physics mesh. Alright, so now we have this lovely cord that is just sagging into outer space because there's nothing underneath it. To make it look realistic, we're going to start using some collision objects. So for just a minute, for demonstration purposes, we're going to turn off the rotation target and the location target, the spring target. Alright, and just let it fly free with total freedom. And I think I'm going to turn these hitters down a little bit. 5. Yeah, so it runs a little faster. Alright, so to make a collision object, it's fairly easy. Let's add a cylinder for a test case. And I don't know, take this way. Seems okay. And we just click on Collider. Don't worry about friction for now. It's currently disabled for this video because it doesn't really matter. I will cover that in a later tutorial. So now that this object is set to a collider, our armature is going to collide with that object. And collisions actually work pretty well as long as you don't get too crazy. It'll wrap around and slide and stuff. So that would be an example of a collider object. Now I've already created a table to go under my lamp. It was just hidden. So here's my table, and we're going to set these guys back up to, wait, one of these was the, yeah. So this is a spring. We're going to set it to 1. Immediately the cable comes flying back up there. We're going to set the rotation target to 1, and then it like spins it so that it looks like it's hooked to the base of the lamp, which is exactly what we want. And now we're going to make this table a collider by clicking Collider, and you know the armature's underneath it, so it doesn't really know what to do with that. Just reset it to where we had it at the top, and now it's where we wanted it to be, except that we move this around so it's kind of freaking out. Alright, now for this to look natural, so now it's, you know, sort of landing on the table. In real life, you'd probably have the cord sort of laying partly twisted up or something. So let's kind of stretch this out into some shape or whatever. And maybe we want to like have this cord be like old and stiff, and somebody like wound it up at some point. So we'll turn the angular itters up a little bit to like, I don't know, 10. It's going to make it a little stiffer. And then we're going to take the pose target, and we've got individual origins set, and we're just going to sort of wind that thing up. Real tight. That will make the cord kind of look like it's old and has issues. Kind of like a real cord would. Alright, so now we've got this kind of twisted up, nasty looking cord that might look a little bit more realistic, and you know, feel free to do whatever you want with your cord, but I'm going to do that with mine. And gonna move this down into where it would be like laying on the table if nobody was around. So it would be kind of like, this might be how you found this lamp when you walked into the haunted house and started exploring and found this strange lamp with nothing else around it. And then I want, when I reset, I want it to go back to this exact state. So I'm just going to save this state. And the way to do that, select the physics mesh here, and it's managing everything with these shape keys. So it's like keeping track of its current state with this current shape. You want to create a new shape for mix, and this is just something that's built into Blender. So new shape for mix, and now we have this key that it matches its current state. So like your, you know, starting state of the physics mesh, which is hard to see because of this, looks like this. It's straight. and its current state is this, and then this new one we created is this copy of its current state. And back when you select the physics rig, as long as active reset or active shape reset is set, then when you go back to frame 0, instead of going back to straight, it will go back to whatever that shape is. So I went back to frame 0. Like if I run it now and I move this thing around, you know, and it's got all this warping to it, go back to frame 0, and now it's back to my saved starting state, which is that shape key that's on the physics mesh here. And maybe I should like name it coiled or something. Alright, so I like this as my starting state, and now I want to, just for the time being, I'm going to disable animation so my cord just sort of stays there and doesn't do anything. And right now, like, you know, it doesn't move, but what I'm going to try to do is animate this cord like going up and plugging in. So for convenience, I'm just going to make a duplicate of the head so that I can see it. And it's currently parented to the armature, so I'm going to clear parent and keep transform so it stays there. And I make it the child object of my controller thing there. So now when I move this empty, it's going to move this visual cord thing. So I'm going to go to frame 0 and keyframe its location. And it's probably going to sit there for a second after the animation starts, so we'll keyframe its location and rotation again. And then, like, somewhere down the timeline, however long you might think it would take to plug in a cord, something like that, we're going to, like, move it up here and, like, plug it in. So move it like there and, like, rotate it where it sort of is straight and put it where it'd be like plugged in. And yeah, that looks pretty good. So now we're going to keyframe the location and the rotation. Now we're going to duplicate that because we want the cord to slide out straight. So that's going to take maybe that many frames to slide back out. To nearest, yeah, there we go. Now this is going to slide out like so. And so I should now have an animation of the plugging in the cord part. Alright. And we have, you know, it going down and moving in a way that it wouldn't actually move. So somewhere in between here we're going to just add some randomness. Like maybe in real life, maybe in your project you're going to have a character's hand moving to plug in the cord. And the character like picks up the cord and moves it up here and rotates it like this, and then rotates it randomly. And so we do the rotation and location. And so now we start here, and the cord kind of gets picked up by the character, and then they like move it over and they stick it in the socket. And that's how it plugs in. And isn't that just lovely? Alright. So now we can get rid of this visual one. Which one is it? I don't want to get rid of the one that I'm trying to keep. That's the one I want to keep, and this is the one I'm getting rid of. Is that right? Yes. Alright. Now I can turn the animation back on. Right here. And get my table back out. And now I have this animation of the cord picking up, sort of moving kind of randomly, and then plugging into the socket, just like I wanted. Isn't that lovely? Alright, now I could just like record, like do a render and show it there, but it lags a little bit because it's trying to process all those like angles and stuff. So to make this a permanent animation, we're going to record it. So we select our physics rig and we go up to record to keyframes. We're going to check that. And let's make sure we know where we're at here. So we're on frame 0. We want to record every frame. So every one frame. If you set this to like 3 or 4 or something, then it will put a keyframe every however many you set it to, 1 every 10 frames, and then it will just like use Blender's typical interpolation, Bezier or vector or whatever you set your handle type to interpolate between your keyframes. And you might want to do that to save data or something, or to smooth out the animation or whatever. For my purposes, I think if I set this to 0, it just runs every frame, so I'm just going to set it to 0. And then the starting frame, where you want to start your recording, you can set it to something other than your current frame, so that you can like use your timeline to do motions and things and not worry about like where you're recording. So like if I set my record frame to 50, then it's going to start recording on frame 50. And this will create an action for it to record to. So you just name your action something that's maybe less silly. So we're going to call it chord action. And now what's going to happen is, with this checked, as soon as I start running this, I let it run until I want to stop, it's going to start at frame 50 and just keep recording the motion of all of these bones in the rig at every frame, provided everything works. Anyway, I should be good to record, so we're going to record this now, and you'll see the animation is playing and it plugs in the cord, and I'm just going to wait for it to kind of stop moving because it's sort of floppy. And we'll see if it worked that time. So we're going to turn the recording off and the animated off. We're going to select that new chord action and see if that one looks right. And, oh yep, that one looks right. So we have our cord plugging in just like we wanted it. Yay! Alright, so that's the basics of how to do an extension cord. Next we'll look at how to like wind up a rope on a spool, which should be pretty simple. So we want this rope to wind up on a spool, and I've already made my 3D model of my rope, and I just extruded some cylinders and twisted them with like proportional fall-off editing, wherever that is, to make the rope. And now that I have my rope, this lovely gigantic rope, I'm going to add, let's see, first of all I want to snap the cursor to the top of the rope, and then I'm going to add an armature, and let's see, I want this armature to be like pointing the direction of my rope, so I'll set this to 3D cursor so I can pivot around. Just rotate it. Actually, if we rotate it 90 degrees and then rotate it 90 degrees again, we don't have to reset the bone roll, I think. Yeah. Blender's rotation, it's a little weird. I can't see it, so we're going to go to this and turn on in front. And I've sized everything in the real world so that I can just extrude my armature segments at 1 unit again. So Z, -1, and then I'm going to repeat that. Until I have it all the way down my rope. And now I want my rope to deform with the armature, so Control P, and we'll use automatic weights again. And it's going to take it a minute because it's big and stuff. Alright, now in theory, my armature can deform my rope, which it seems to be doing. So, yep. Alright. Okay, I want to set up the physics on this thing now, so first thing I gotta do is make a pose target for it. So we're just going to duplicate it like this, and we're going to set the pose target like this, and that creates the physics. So theoretically now it should just work, which, yes, it does. Okay, so the physics is running. And I want it to reset at frame 0 again, so we're going to set that to 0, and notice it's pretty slow. The reason it's so laggy is actually just because it takes Blender some time to compute the armature on this thing. So we're going to turn it off for now. And now the physics can run. And we don't actually need to see the rope, so we're just going to hide it for now. Okay, we need a controller on this thing, so we're going to add a head target and set the spring to 1. And now, in theory, okay, I can control my rope. And the armature's out of sync again, so we're going to clear parents. Alright, now I have my rope object behaving more or less the way that I want it to. And you'll notice how it's kind of like slow motion. Part of that is because of the lag, but part of it is also you can fix it basically by controlling the number of frame steps in between each time step. So if I go down to subframes here, I can set that to something and it will run more slowly, but it will run faster in real world time. So basically what happens is it does more iterations between each frame step in Blender. So if you want to change it, like say you're getting this sort of slow motion looking effect, you can just scale down the keyframes after you've recorded it to make it run faster in real time. Or depending on how fast you want it to move relative to other things that are animated, you can change the subframes here, and that will basically just do more computes in real-world time in between each time step, which will make it look like it's moving faster in time. So because it's annoying to work with when it's doing that, I'm just going to set it down to that. And now, this is kind of in the way, so I'm just going to move it over here. I want to add a spool type object. So I will add, I'm not going to do anything fancy because you can model your spool and add details to it later. So I'm just going to use a cylinder. And I want it to be of such a scale that it matches kind of the resolution of the bend that I expect to get on my rope here. So if I made it super tiny and I tried to wrap it around a rope that only has segments every 1 Blender unit, then a rope's going to look sort of jaggedy and weird. So I'm going to make it, you know, some size that makes sense for where my segments are in my rope. And then I'm going to start on like one side of it, and then the rope is going to move along and coil up as it goes. So I'm just going to move it so that it starts like on this side of the rope. And I also want to be able to see it spinning. So I'm going to make a little bit of a modification to this thing. Oh, I want to get rid of these faces. So get rid of those faces, and then I want to add some faces that will just let me see it. So that should be good enough. And then I'm going to put a material on it so I can see it spinning. And we're going to add 2 materials. One will just be a spot on it so that I can see it spinning. We'll make it a different color. Alright, I need to animate this cylinder to be able to turn. So while I'm doing that, I'm going to just disable animations on here so I don't get any kind of lag. And I'm going to keyframe its rotation. And then I kind of want it to rotate slowly because it will compute better. It will basically, the simulation will run cleaner if it's going slow. So Let's run it for a little bit. Well, I don't know. I want to imagine like how long it would take for it to turn like this much. So that's probably about right. 20 some frames. So we'll keyframe the rotation, then we'll let it run for 20 something frames, and then we'll rotate it a little bit. And keyframe the rotation again, and now we have this little bit of rotation here. We want that to continue out into space, that rotation to continue for quite a while. So I'm going to go into the graph editor here and find that rotation. Okay, there it is. Alright, and I want to change the handle type to vector, maybe, or just, I could also just scale down these. Scale them down to like 0.1 or something, so that it doesn't start real slow. I want it to move more continuously. We're just going to keep it going at roughly the same angle so that it rotates at the same speed. And now I should be able to get multiple rotations. So yeah, it'll just keep spinning on the y-axis, which is what I want. Alright, now we want to make this guy the child object of this guy so that it will coil up on it. And then when we re-enable the animation, then we'll get our thing moving with it. And this has to be set to collider so that it will wrap up on it. And there you have the rope wrapping up on the object. And you'll notice that it's like stretching a lot. So like the space between these guys is pretty big. I don't want it to stretch that much, so I'm going to turn my linear iterers up, and I don't really care about the angular iterers at this point, so I'm going to turn those down. And I'll try like 200, and it'll lag a little bit, but it doesn't stretch nearly as much, and that gives it better results, slightly more accurate collisions. So that should be pretty good. Alright, now if it just keeps spinning, it's just gonna like overlap itself. So I need a way to make it like move as it's wrapping up. So for that, I'm just gonna like artificially force it over. So I'm gonna add another cylinder. I don't know, like right here for now. And I'm going to rotate that. Actually, I want it to be oriented that direction. So I'm going to use this to just push it over. And now this one I want to set to 0 friction, because the rope is not going to stick to this at all. It's just going to slide freely on the rope. And if I set it, the friction up to 1, then it's going to sort of like catch on this thing. So I don't know exactly how far it needs to move in order to push this thing over, so I'm just going to kind of guess at it. I'm going to guess that it'll take, like, I don't know. Let's disable this for now. Don't need to see this at the moment. I'm going to guess that it's going to take 5 rotations. Should be about right. And I reset that. So we're going to keyframe it here. And then we're going to go our 5 rotations and well, we already keyframed the location once. 1, 2, 3, 4, 5, roughly there. That work? Yep. Alright, and we're going to do the same thing where we scale down the handles. so that it doesn't like start and stop really slow. That seems okay. I gotta set this thing to a collider, friction 0, and then we'll start our animation and see what happens. Hopefully this will sort of push it over so that the coils don't overlap. And I'll probably have to run it a couple of times and adjust it to get it to go into the right place. Like, it seems like it's moving reasonably well for where it needs to go so that the rope doesn't overlap itself. I might actually have to look at the rope mesh to see if it's in the right place. So it looks okay. I'm just going to call that good. And I'm going to go ahead and just start baking it. So I'm going to set this to record, and I want the skip frames probably to be 0 in this case, because when you're working with this many bones, Blender's interpolation doesn't necessarily work very well. It's going to have some glitches in it. So let's just keep the skip frames to 0, set it to record keyframes. Make sure you're at frame 0 when you turn this on, because any movement that you do after you turn this on, it's going to get recorded. And then record frame of 0 is probably fine. Just start it here, because we're recording to a separate animation or action anyway. So I'm going to name my action rope action. And now I should be able to just run it. So I'll pause this while it's running because you don't need to see this whole thing. And then we'll check on it in just a second. So I did have one little issue when I tried to bake, and that was just that the rope was actually colliding with the cylinder here. So I'm just going to move this cylinder out of the way. Actually, I don't want to change my animation, so I'll just move the mesh kind of out of the way. Maybe down a little bit so that I don't accidentally collide with it along here. And then we'll try baking again. Okay, so I finished running this thing, and it looks like it wound up on there pretty nice, the way that I wanted it to. The ropes don't, or the rope doesn't really overlap itself too much. Might be a little bit too close here, so I could tweak it and run it again. But now I want to see what it looks like, so I'm going to turn off the physics animation, and then I'm going to find my rope action, which seems to be okay, and let's see what it looks like. So this is kind of annoying, so I'm going to hide that. Yeah, it looks pretty good. Oh, that was interesting. It ran into my collider right there, so as it's spinning around here, I see it kind of flop down like a rope would, and then it hits that other collider and drags against it. Yeah, I only recorded it up to there, so the cylinder keeps moving, but the rope stops. Alright, so let me see if I can find my rope object, and we'll turn on the armature. And not exactly perfect, but probably passable. Looks pretty good. I had all this stuff so I can see just the rope winding up, and yeah. Alright, so there you have it. Rope winding up on a spool. Alright, I guess the next tutorial that I'll do later will be probably animating some kind of an insect character to walk around. So until next time, happy blending everyone.